Hey, good morning. Whew, 9 a.m. We got the 9 a.m. session. At least it's not the 9 a.m. session tomorrow because there's a party tonight and most people will probably go out tonight. So at least this is a fresh 9 a.m. session. So
who cheers for 9 a.m.?
Yes, I do, because it's our session. We should be cheering for 9 a.m. sessions. What the heck is going on in this room? Wow, thank you all for showing up. I'm Ed Marczak.
I'm Russell Hancox.
And before we even get started, the very first thing I want to do is thank all the people responsible for putting on this conference. I've been coming here 4 or 5 years. I think this is your first year here. Everyone does a great job. Thank you, Dave, Rusty, Gretchen, and Justin, and all the people running the AV and helping set up the room. So big round of applause for them. So thank you. Also, before we get too deep into this, here's a URL that you can look at. This is a Google Doc, and it contains pretty much every thing that we mention in this talk with links to all the open source that we're going to talk about. So if we do happen to go too quickly through a slide, you don't have to furiously scroll it down or try to ask us to go back to a slide. You can look at this, it's live right now, and it has links to all the open source software that we're talking about. So, I mentioned that we work at Google. Russell, what do we do at Google?
So we work in the Macintosh operations team, or MacOps as we're informally known, and we manage all of Google's Macs. Some of you may be surprised if you haven't seen our team speak before that we have a lot of Macs. As of this morning, our 30-day actives are 64,000 machines that we manage. Apple used to tell us that that was the largest they'd ever seen. I don't know if that's still true. I think it probably is.
Probably. They used to qualify it. When we were at around 30,000, they would say, oh, you're the largest non-government installation, or you're the largest managed installation. So.
But then they stopped qualifying it.
I think they've stopped qualifying it, and I think our salesperson now has bought his own island somewhere.
And that 30,000, that was like 2 years ago, right?
Yeah.
So we're also growing very quickly, but our team is not growing. We have 6 engineers and 1 manager looking after all those machines. And we can only do that because of lots of open source software, some of which we wrote and some of which we just use and sometimes contribute to. But before we go through all of the open source software we use, Ed's going to give some history.
Yeah, so I think to qualify that a little bit, so we're 6 people that manage all these Macs, but we are also in the very fortunate position of not also being the support organization. So we have a great support organization that's sort of this front line. They see the questions like, why won't my computer print? Or did you turn it off and on again? Type answers. We never really see those. We get to do this sort of very high level vision of what Mac OS should be to make our users the most productive that they are.
We don't see Jen. We never see Jen.
Yeah, we never see Jen. So anyone who has ever seen me give a talk knew that this slide was coming up. So we all came to this conference, and you all decided to come to this session. I don't know what you hoped to get out of this. Anyone care to share why you're here in this session instead of one of the other sessions that are going on? What you hoped we would cover? Anybody? Yeah? That would be great. We would love that as well.
So you can go.
So yeah, actually talk to us after we're done. There are some things that we are working on with single sign-on. I don't know if it'll make it that smooth, but that's good feedback. But yeah, we would like that as well. Yes?
I would say because that's the answer that I get when I'm trying to figure out where Apple is going. In terms of enterprise and things like that. So I'm looking to have the tools that I can use if they fail me.
There you go. And that's what we've found. We've found that we really need to chart our own course. And yeah, like Russell said, we couldn't do it without open source. There's just no way. So we are at this conference, Penn State MacAdmins. And the most prevalent thing there for me is the word admin, and of course that is short for sysadmin or system administrator, and we have a very rich history. So I put together this little timeline that talks about this history a little bit. Back in 1939, we got this thing called the complex number calculator, and this was a computer in the most strict sense. It computed numbers. It took jobs away from people who were computers, because companies that needed computations used to hire people to do most of this stuff by hand. So here we had an entry into computing and no system administrator. You know, the person who developed it, maintained it, supported it, sort of did everything. And you'll find that pattern continuing on until later on. The Z3 computer, 1941, developed by a German. And if you look at the date, 1941, you can imagine this got destroyed in a bombing run on Germany during the war, but this is credited as being one of the very first sort of multi-purpose computers. The bomb, for people who know their World War II history, Alan Turing is credited with creating this very single-purpose computer to help break the German Enigma codes. But again, the person who conceived it, built it, system administrated it, sort of did everything to maintain that one computer. And it was purpose-built for a single reason. The Harvard Mark I, I mention it because some of you computer sciencey people might have heard of the Harvard architecture. This gave way to the von Neumann architecture at some point. I don't think any current computing device uses the Harvard architecture. The Colossus, this was another very purpose-built machine. Everyone sort of heard of Alan Turing and the Enigma codes. What the part of the story that most people don't get to hear is later on, Germany came up with more difficult encryption schemes, and this was another machine built to break those codes. Again, purpose-built. The people who built it, maintained it, you know, if there was a problem with it, they were the ones who had to fix it and sort of be the system administrators. ENIAC, almost the first digital computer. And actually, I'm going to go back to that one for a sec. ENIAC, you know, you can see it's the size of a room. You're almost literally walking through the computer as you use it and program it.
Can't trust computers that big.
I wouldn't. The Lyons Electronic Office, built by the Lyons Tea Company in Britain, a very single purpose-built computer for office automation and shipping and calendaring and those types of things. They did produce a number of these systems, and this is kind of where you start seeing people needed to just administer a system. So 1950s are the birth of the system administrator in some respects. The IBM 7000 series mainframe, the first mainframe that IBM built based on transistors instead of valves or tubes. And IBM is obviously a huge player in this field and birthing system administrators in some respects. The IBM System 360, this was a mainframe that was made to work with a whole range of peripherals. So now, of course, printers, we all know how much we love supporting printers and how well they always work. So yeah, you're seeing systems growing in size and needing people to maintain them outside of the people who created them. DEC, the PDP, of course, a very important milestone in computing. Do we have anyone in this room who's ever used a PDP? No? Okay, we're still a little early on in that. HP jumped into the game, making these sort of workstation-sized setups. And of course, now you need people to be running cables over to these machines. So you have sort of networking system administrators coming along. PDP-11 with Unix. I mentioned the PDP-11 very specifically because there was a version of Unix for the PDP-11, and that meant multi-user. So that meant you needed an administrator or someone who could come along and add accounts and watch disk space and make sure no one was using up too much. So very sort of system administrative tasks. And then, of course, at the same time, you have these personal computers coming along. The Kenback was credited with being the first personal computer, and you have no monitor, you know, input and output with switches and lights. but no system administrator. You're sort of getting this hobby kit and putting it together and watching it work. I have to mention the Xerox Alto, mostly because it inspired the Macintosh to have a mouse and menus and the mouse pointer and everything. And of course, 1976, the Apple I. I forgot the number. What was the number?
200.
200 Apple I's ever produced. So I can't say that I ever got to use an Apple I. But the very next year, we got the Apple II. And I did get to use an Apple II. And education used to be a very important stronghold for Apple. Apple gave away a lot of computers and gave discounts to educational institutions. So you saw these Apple IIs and Apple IIes and Cs show up at a lot of schools. And teachers sort of became system administrators this way, intentionally or unintentionally, many times. And 1979, the VAX, versions of Unix for the VAX. So of course, this is a much bigger system. System administrators needed to add users, remove users, accounts, watch disk space. Commodore 64, I mention it mostly because it was the best-selling computer of its time. Who owned a Commodore 64? All right, yeah, more hands. All right, my people. Very nice. But again, sort of a hobbyist computing device. I can't remember them ever, there were word processors for the Commodore 64. I don't ever remember it being used actually in an office that much, but this was sort of the takeoff of needing someone to help you with your computer, which basically is a system administrator. The Apple Lisa in 1983, looking a little more Mac-like, right? IRIX Unix for SGI MIPS machines. And this is one of the things that I have a real strong memory on, working with some graphics companies. And the people who were developers on those systems were usually also the system administrators. They didn't hire separate people for this. So you'd be sitting down, writing code for 3D shaders and 3D graphics programs. And then someone would come over and say, hey, we just hired this person. Would you give them an account? And all right, you'd go over, you'd give them an account. And then you'd go back to writing code all day. So system administrators and developers used to be much, much more intertwined. Then, of course, as systems got more and more complex, people needed to specialize. And system administration became sort of this full-time task, and development became this very full-time task. So I feel like, and I've been speaking about this for a few years, system administrators sort of lost this ability to code. And we need to get that back in a lot of ways. And I think we have been. Over the last few years, I've been really inspired to see more and more people, especially in the Mac community, jumping into writing code and releasing open source software. And I will end this timeline with the Apple Macintosh, which is the reason we are all here. If not for this computer, we would all be at a different conference or something, I suppose. So system administrators have this sort of very rich history where, we started off very intertwined with developers and development, and then as systems got more complex, we needed to specialize a bit. But as far as open source, here are some programmers programming the ENIAC, and how would you share source code like this? How would you even share what you were doing? You gotta take pictures of where everything's plugged in? Probably not. So, way back with these early machines, there was no sharing of source code. Most of the time you're just lucky to get anything working and running at all. But of course, here we are, talking about open source. So I wrote down some milestones that I think of that are important for open source. One of them is just, of course, going to be the internet and Usenet. Anyone ever use Usenet? All right, wow, a lot of hands. That's nice, because Russell makes fun of me when I mention Usenet. He wasn't born yet. That's my life. But Usenet, for those of you who might not know what it is, was a very early, sort of like a bulletin board system on running over the internet. And you could post messages and retrieve messages, and very often developers would use it as a way to collaborate. So it was a collaborative tool. 1983, Richard Stallman, started the GNU project. And, you know, say what you want about Stallman and his, you know, policies and his fervor for what he does. This was an incredibly important milestone. So I mentioned those earlier systems that had Unix on them. Unix started off, and a lot of those earlier machines started off when companies bought them. You would get the source code to the machine, and the HP or whoever your vendor could send you patches, and you can recompile the kernel pretty easily. And over time, even things like Unix sort of got closed up, and companies would ship these proprietary versions of Unix or not ship the source code and make you wait for patches. And Richard Stallman saw this as a huge problem. And there is a story behind why he did this, all because of a printer. Again, it's always the printers. Decided that we needed a free version of Unix again. So he decided that they were going to clean room engineer all these Unix utilities, and we're going to share the source code. So no one was using the term open source in 1983. They were just going to share the source code. Another way we used to share source code, believe it or not, magazines. I remember, this was 1984, I remember buying this particular issue of Compute, and they would not only talk about a program, but they would give you the source code, and of course you would go sit down and type it into your computer. You didn't go download the source code, you typed it in from the magazine pages, and of course you'd run it and you made a mistake somewhere and it was horrible. But I love the cover of this. Look at this. The clown has all these balloons with Commodore 64, IBM, Apple, Atari. You know, you got source code for all of these different platforms. Compute, for those of you who do remember, they eventually branched off a specific magazine just for the Commodore 64 because it was so popular. But yeah, this was another way we used to distribute and share source code. 1991. Linus Torvalds posts a message to Usenet, of all places, saying, hey, I'm working on this thing. It's going to be a Unix. I don't know if it's going to be important, but you might want to help out. It's going to be a free version of Unix. And of course, that turned out to be Linux. A very important milestone in open source and sharing source code. 1996, the Apache web server comes along, and more importantly than just allowing people to run a web server, they gave all their source code away. It's free open source software. And that certainly led to developments of things like mod PHP and all these modification systems that you can then plug into the Apache web server itself. I don't know if Apache is still the most popular web server, but it was for a very, very, very long time. Another way we used to share source code were dial-up hosts. Most of these dial-up hosts gave way and just became gateways to the internet. The Well, certainly a very important one, had local chat rooms, and people were able to share programs and source code that they were working on. One of my favorites, though, is CompuServe. Anyone use CompuServe? Again, oh yeah, good stuff. So CompuServe acted as a bulletin board in many ways and had these specific rooms for topics, and of course a lot of topics revolved around computers and computing and technology. And I remember back then being introduced to this guy, a programmer named Jury Monkey, and he's a programmer from Finland, and this was back in the classic Mac OS days. And he was a game programmer. And not only did he share his games and post them for free, he shared the source code. And this was mind-blowing to me that this person from Finland, halfway around the world from me, could share this stuff. And when I ran the game and watched these amazing visual effects, for the time, pretty amazing, I had the source code to see how does this work? How do I do this? I could load it up and step through it. And you know, again, possibly for people before you were born, you know, we used to work on monitors that were 13 inches and didn't have very high resolution. So I would take this source code and I would print it out. And then you could stack the pages so you could trace the flow of things a little bit more easily. But yeah, this is one of the earlier things that I remember about using CompuServe, people sharing source code. Another thing I remember from those early days on CompuServe was a ray tracer, a 3D ray tracer called Pavre, persistence of vision ray tracer. And it's still going. I went to their website when I was thinking about it for this talk, and here's an image someone created in 2008. And I thought that was pretty cool. Like, I would think that was almost a photograph. And this person in 2008 said they got a new Athlon chip, and it took them 4.5 days to render this, and they were really proud of that, which was pretty cool. But I was looking for a wiki or something on their site that talked about, the history of POV-Ray, and I couldn't find anything like that, but I did find this FTP site. And they have their official 1.0 release in 1992. So here's a group that's been sharing their source code since 1992. And then along comes, in 1997, Eric Raymond releases a paper called The Cathedral and the Bazaar. And this picture is from the book. So he released this paper electronically. It was made into an actual book in 1999, but the paper was released in 1997. And this is really the first time you see the term open source. And the Cathedral and the Bazaar paper came out of a meeting with some very high-level, important people from Silicon Valley. They had this meeting and they were discussing a lot of different things. And one of the people at this meeting is Christine Peterson. And she is the one who suggested the term open source for people who were sharing their source code. So she's the reason that we use the term open source for sharing our source code. She now runs something called the Foresight Institute, which promotes the use of nanotechnology. So, she's kind of smart. But yes, she coined the term open source. And it's from that same meeting that Netscape was encouraged to share the source code from their browser. And that's another milestone. You mentioned there's a documentary on this.
Yeah, JWZ was the one that ran most of the open source effort. There's a documentary and it's very interesting. I can't remember the name.
Yeah, but anyway, Jamie Zawinski was working at Netscape at the time, and he, helped get it cleaned up because, we all have source code that we might not be too proud of, that, you needs a little cleanup before you share it. But yeah, I know, enough history, right? Ed, shut up, shut up, shut up. Shut up. So let's get into some more of the technical details. If you are involved with open source at all now in 2015, you probably know that means using Git. So for those of you who have never used Git and you've heard horrible things about it, don't be scared of Git. We're going to give you the world's shortest lesson in Git right now. Really, if you're just using other people's source code, there are only a few commands you need. The first one would be git clone. And someone will even probably just give you the whole command, and they'll give you the URL. So someone will say, oh, you want that? Just go git clone, and then it's URL. Git :/ blah, blah, blah. If you see the git URI, that means that they're running their own Git server. Much, much, much more commonly, you will just see a plain old HTTP link. So go git clone this repository. And they'll probably even give you the command with git clone in it, so you can just copy, paste it into terminal. And when you type this and hit return, what will happen is Git will create a directory under your current working directory and copy that entire repository from the source onto your disk. And not only does it copy the source, but it copies the entire history for the repository. Every commit message, you can go back through the history of all the commits in that repository. But you will be looking at the latest version of that source code. So you use this source code, you compile it, you're enjoying it, and now you find a bug. You report it to the person that you got the source code from, and you say, hey, there's this bug. And they go, oh, thank you very much. I fixed it, I found it. Go get the latest version. So now you need the latest version of this source code. You go back onto disk, you change directory into that repository, and you type git pull. And that will refresh your repository from the source with all the latest and greatest source code. So I don't want to get too deep into Git because at this very conference, there's a session on Git. Git for system admins. Justin Elliott, Friday at 10:45. So if you're interested in Git, you might want to attend that session. So now we want to talk a little bit about open source that you can use. And I'm going to let Russell take that.
So we're going to start with most of the stuff that we currently use. But I'll start with the things that we didn't write. Because in some ways, those are almost more important than the ones that we did. So the first one is crankd. Crankd runs continuously on the machine and monitors for events. It can monitor for a number of events, including power state changes, network state changes, like if you've connected to or dropped off a network. And it can also monitor for application launches and exits. And you can configure crankd using a normal plist. That's fairly clear. But the first key, the NS Workspace, will launch application notification. It's very verbose. You can thank Apple for that. That then launches a Python script, and you can see in the array there's NS Workspace Handler, that's the class. And then onApplicationLaunch is a method. And that's the code that actually runs. And you can do anything you like when these events happen. You're running some Python code. You can make it run some other program if you want to. We tend to use Python. So we monitor all application launches. So if somebody runs Safari or if they open iTunes, we can record that information, and we can use that later to work out what people are running on their machines, and that can help us make policy decisions.
And for those of you who care, crankd itself is written in Python. It's a pretty good example of Python code.
Yeah, it's PyObjC sort of stuff.
Yes.
Yeah.
C types. It goes pretty deep, actually.
Yeah. Something we did write is the application usage stuff. You can grab that from our repository if you care about how we record application starts and things. And that's an example of how to use crankd as well.
The application usage stuff, people have sort of picked up on that. That's really useful. So we record anytime someone launches an application, and then we shuffle that information off to a database. So we can find what's sort of the most popular things that people are running.
And how long they run for.
And how long they run for. I don't think we track. We could track it, but we don't because it's a pain.
So this is probably one of the biggest pieces of open software we use, Puppet. I'm sure many of you have heard of Puppet. It is a configuration management tool. It does continuous management of state on a machine. So we say we want our machines to have a particular set of state, and Puppet ensures that this machine stays in that way. This is great for us because our users like to mess with things. They like to delete configuration files. They like to disable management tools because they're engineers. Things get in their way. We have heard Puppet referred to as a virus. It isn't. I guess anything that uses resources is a virus to some people. But we use that to put files on the disk, to manage configuration files, to make sure they have certain keys in, and to keep certain launch daemons running. We've been using Puppet for a long time at Google, and other platforms teams at Google use it as well. So if you run Windows or particularly Linux at your company, then Puppet is a great thing that you can use across multiple systems. Puppet is actually an open source project and a commercial product. There's a company that supports Puppet and sells support and extra features if you're willing to pay. A lot of the Mac stuff you don't really need to pay for. You can if you want to, if you want the extra support, but we've never found that necessary.
For those of you who remember the history, Puppet Labs scooped up a lot of prominent people from the Mac sysadmin community. So they do have a lot of Mac OS X expertise, which is pretty interesting. I just feel that they know the Mac people are going to use the open source product probably more than paying for it. So you don't always see the support reflected on the OS X side, but they have deep OS X expertise. In fact, the first product that we mentioned, crankd, was written in part by Nigel Kirsten, who's now the CTO of Puppet Labs.
So Puppet works with another project called Factor, made by the same people. You usually install them together. Factor is for collecting information about a machine, and Puppet then uses that information to work out what to do. You can use Factor standalone if you want to, and it is fantastic for collecting information from a machine, and you can extend it to collect things that it doesn't know about by default. So we have hundreds of facts that we've added about things we want to know about, like what certificates are installed on the machine, or whether there's a HTTP server running at any time, because we generally don't want that. Normally when you use Puppet, you have a master, and that serves down all of this configuration information to the clients. And that's protected by SSL or TLS, and there's a server that also issues the certificates. There is another way of running Puppet, which we've started doing, called masterless or serverless, where you don't do that, and you just put the manifests on the machine and have Puppet continuously read them from the machine itself. And we do that by distributing those manifests separately using just a normal HTTPS server. We find that works better for us. Whatever suits you works best. If you want to know more about how we do masterless Puppet, please feel free to ask us. Another project we use is the Luggage. Is that also written by Nigel?
No, that was written by a guy named Joe Block, who wrote it while he was at Google. We never got around to open sourcing it. He left Google, but then asked his manager, hey, can I open source this thing that I've been working on all this time? And they said, yes, sure. So yes, it was written by a now ex-Googler, and we still use it internally.
So we use this for package building. So we make Apple packages using the Luggage. It is based on make files, which can be a bit ugly, but they're fairly easy to understand once you've got the hang of it. The thing that we really like about the Luggage is that we can create one of these make files for a certain package, and then it's reproducible. We check that in, and anybody can come along and just run make, and it will make the same package over and over again, no matter how many times you run it. There is a new hotness used by a lot of people now called auto package, but we've stuck with the Luggage for some reason.
We've been looking at auto package. We just haven't made the jump yet, but
yeah.
Like we said, we have a long history with the Luggage, and all of these make files are already there for us.
We have to recreate them. That would be annoying.
We'll get an intern to do that.
That's a good idea. So once we've got these packages, we distribute them with Monkey. I don't think Monkey needs much of an introduction here. So I'll just say about how we use Monkey. A lot of people use Monkey for everything. We don't use Monkey for distributing configuration or scripts or just plain files. We only use it for distributing software. And we have a fairly simple setup as well. We don't have lots of complicated manifests for different people or different departments. We just have unstable, testing, and stable. That's not very granular, and we sometimes find that things don't get tested very well that way. So I'm going to talk about how we use experiments later, which works with Monkey. Monkey's a fantastic project. We've been using it for a long time. And if you'd like to know more about it, the lead developer will be talking about it later this week. So Greg will be talking about it tomorrow, actually, at 10:45. So another thing that we have to do is, when we get a machine from Apple, we don't necessarily trust that it has the software on it that it should have on it. We're a bit paranoid, with good reason. So as soon as we get a machine, we erase everything that's on it and replace it with an image that we know is good. And we use auto damage to do this, and it has a number of packages that we add to the default install. We don't add many, just enough to get the machine to bootstrap itself. We don't like having fat images because that means more work for us later on. We have a strange history with this because we used to use instaDMG, which some of you may remember. That worked for us for a while, and then it stopped working for us, so we wrote another project internally called CanHasImage. And we used that for a long time, and we kept saying we should really open source this because other people might find it useful. And then each year we kept saying, yeah, we really do need to do that. We'll do it later. And then when we went to actually do it, we found somebody had written auto damage. We're like, oh, well, that's annoying. It's better than ours. It's not quite as good for our needs, but it has a UI, and the code is cleaner. So instead of releasing ours, we started using AutoDMG. We did publish the code for CanHasImage, but you should probably not look at it. So now the stuff that we wrote. GMAC PyUtil is something that we use tremendously. It's used all over the place for us. It's a collection of Python modules. So we have wrappers for things like directory services, generating profiles, gathering system configuration information, getting state about the machine, like whether it's on battery or whether it's connected to a network, and for doing power assertions, which we find a nice way of, if a machine's about to put itself to sleep while it's running some management tool, we can make that pause for a while. There's a lot of stuff in that repository. It thankfully is fairly well documented in the actual code, and you can just drop into an interactive Python terminal and import GMAC PyUtil and play around with all the things that are in there. Most of it shouldn't do any damage, generally. If you're using just normal Python to do interactive stuff, you should probably check out bpython, which has tab completion and shows the documentation when you do that. It's really nice.
And is open source.
And is another way. Of course it is. So one of the big things in GMAC PyUtil is experiments. So as I said before, we have unstable testing and stable, and we do that in Puppet and Monkey. And that worked for a while we had fewer machines. But now that we have 64,000 machines, we don't have as many testers as we need. And getting people to agree to be guinea pigs has proven to be difficult. So now we force them to be guinea pigs. So when we've got something we're not 100% sure about, or we think might be risky, we create an experiment for it. And all that involves is adding a few lines to a YAML file. It's a very simple format to write by hand. And we really just have to give it a name and a percentage. And the experiments binary that we provide, which is written in Python, will read that YAML file and it will put machines into an experiment based on some hard-coded information on the machine. And this works really well because if we put an experiment to 10%, and we find this isn't really working very well, we can roll it back to 0. And we can fix whatever's wrong, and then we can roll it back to 10%. And the same 10% of the machines will get the experiment. And the other nice thing is that if somebody reports, this isn't working for me because I'm running some crazy piece of software that you did not foresee, they can manually opt themselves out of an experiment. There's not a nice GUI for it, but most of the people who care are okay using the command line.
And there's going to be a session that talks about GMAC PyUtil and experiments. You're missing it right now. You're good. You're good.
So having 64,000 machines, we don't like supporting multiple versions of Mac OS X. We tried doing that before, and it just proved to be a lot of work. Lots of if statements in our configuration. If running 10.9, manage MDNS responder. If running 10.10, manage discovery D.
If running 10.10.4, go back to...
Yeah. So that's proved to be really annoying. So we stick to just having a single OS version. And when Apple releases a new version of OS X, we test it. We've already been testing it with the developer previews, but we test it further. And if we're happy with it, we say, OK, you can install this now. And a huge number of people go, yay, new shiny, and they install it. And then a few weeks later, we say, now you have to install it. You don't have a choice. And then if people go, oh, all right then. And then they install it. And then we have this slow curve of people who just refuse. So when the carrots have failed, this is our stick. Deprecation notifier pops up like this. It covers all of your screens. It can't be clicked on, and you can't type through it. That pops up every hour. That should annoy you enough that you'll eventually do a shoutout. Shortly after the first time we used this, somebody emailed me and said, that's the least googly thing anyone has ever done. So I have work to do.
Yeah, but to be really clear, like this is a very sort of last resort for us. The vast minority of people ever see this because we do get the bulk of people upgraded before they have to see this. But the other nice thing is that we have our security department sort of fully behind us on this because Apple tends to only put out security patches on the latest version of the OS, so they don't want older versions of the OS running in our corporate network either. So, we can always blame it on security.
And we do. So with 64,000 machines, we occasionally have some go missing. People leave them in backs of taxis. People sometimes leave the company and forget to give them back, and we forget to ask or something. So this is our tool for disabling a machine that has disappeared. It works quite simply. If the file vault is enabled on the machine, which it should be on all of our machines, it creates a new user with a scrambled password that nobody knows, adds that user to file vault, and then removes the existing users. So the only person who can log in, there is no password. And that then reboots the machine. We can still get the machine working and get all the data back because we have the key that was escrowed when we first encrypted it. So we have the data, but the person who has the machine has no way of getting that key, so they have no way of getting on the machine. There's a funny story around this. We had somebody who did leave and forgot to give their computer back, and their son was using the computer for an assignment when it randomly turned itself off, and the assignment was due the next day. And he'd spent many hours working on his assignment. I'm sure it was very good. And so the ex-Googler's wife came to the office with the son and came to TechStop. I don't know how they got into the building.
Their manager let them in.
Okay. And they came to TechStop and the son was in tears and said, my assignment's due tomorrow, please. And our TechStop people got the escrow key, and so we gave them a CD with the assignment on, and we got the computer back, so everyone was happy.
We made a child cry, though. And actually, before we even get onto this, a quick shout out to Rich Troughton and to the testament of open source, right? When we open sourced this, I think Rich Troughton looked through it and said, oh, this isn't going to work on the latest version.
Oh, yeah.
And we made some quick changes to make this work on a wider range of OS versions. So thank you, Rich Troughton.
That was a good testament to open source. So with all these management tools that we have running, and all these engineers who like to track what's going on their machines, we have to be concerned with how many resources our tools use. We have a large group of people, for some reason, who run with Activity Monitor open 24/7.
Or whatever. We can do the smallest thing, and people are like, hey, you're using up 0.002% of my CPU. What are you doing? You're killing me.
So Runit is our way of tracking whether our tools are working as we expect them to, or whether they're going off the rails. It works a bit like the Unix time command, but it produces a lot more data, and it prints it out to syslog, so it doesn't matter what we do, it will always be in our logs that we're collecting. So if you've got a launch daemon that's running some tool, all you have to do is put the runit command as the very first argument, and whatever else comes after it, runit will run. I was just running ls here, so it's not very interesting, but you can see how long it ran for, and how much CPU it used, and the memory that was used at most, and Mac messages and context switches and all sorts of things. And I don't think we care about most of those, but some of them are very helpful.
And it's a terrible name. I'm sorry.
Yeah. We're not always good at naming. This is a better name.
This is a much better name.
So at first we ran Puppet. We didn't have Monkey, and we did everything with Puppet. That was terrible. And when we only had one management tool, we had Puppet managing itself, and we thought that was a bit scary because Puppet could break itself. So we wrote Plan B, which was originally a bash script to fix Puppet if we broke Puppet. We now have Monkey, so if we break Puppet, we have Monkey fix it, and if we break Monkey, we have Puppet fix it. So Plan B doesn't get used as much anymore, but we rewrote it in Objective-C because the people who do manage to break both of them manage to break lots of things, like Python and Ruby. It's pretty hard to break Objective-C code. If Objective-C or Cocoa isn't working on a machine, nothing is. So Plan B is our last resort backup. And the one thing that I will mention about Plan B is if you're looking at writing Objective-C code that connects to a server securely and maybe authenticates with certificates, it's a great example of how to do that in a secure way. We've had it vetted by people who know more about this than us. And it's a good example, at least. Santa is a fairly new project of ours, another one that I think is fairly well named, but I may be biased because I named it. Santa is a binary whitelisting system. So it's like Gatekeeper on steroids. It monitors every binary that you run, not just applications. And if it's not in the whitelist, you get this. I don't know how clear that is from there. It tells you what you tried to run and who tried to run it, and what the parent process was and the hash. And you can whitelist things by the binary's hash or by the certificate that was used to sign it. And it's designed to work with a central server that will sync down all of these rules. So we've open sourced Santa. We haven't yet open sourced the server because we haven't finished it yet.
Still writing it.
We're still writing it.
But that will be an open source component, so you can run this all yourself.
Yeah. So Santa was named because it knows who is naughty and who is nice. And if you can't wait for our server, I know somebody in the Netherlands started writing their own server for it called North Pole. Which is annoying because that's the name I wanted. We're also planning on adding more features to Santa so it does more than just binary whitelisting. I know some people find that the idea of binary whitelisting to be horrendously complicated for a sysadmin to manage. So our server does a fairly good job of letting users deal with that themselves by voting. But you could also just run Santa in monitor mode, so it's not blocking anything, but it is at least recording everything that runs and the hashes of those things. And if you worry that you maybe have been attacked or had a virus, it's a great way of going back and seeing from your logs exactly what ran on your machine and when, and who by, and all sorts of details about how it got ran. And we're planning on adding more things like protecting malware likes to put itself in library launch daemons and system library launch daemons. And Apple's going to fix the last one in 10.11, but they're not going to fix the first one because that would break lots of things. So we're going to make that harder for attackers as well. So when you use Monkey, you tend to put up an Apache server, because that's what comes with OS 10, or is easy to set up, and that's how you distribute your packages and your manifests for those packages. That didn't scale well enough for us. 60,000 machines, located on 6 continents, most of them connecting not from a Google network. So we wrote an App Engine server that we manage our packages in. Has a fairly simple interface. You upload your package and the manifest that goes with it, or the package info file that goes with it. And you have some buttons to click to put it into manifests. It's easy to use, and it's been very reliable for us. It serves 64,000 machines. It never falls over.
Sometimes with some very large updates being pushed down to them.
It doesn't care when we put 6 GB Xcode or Apple updates into it and serves it to 60,000 people all at the same time.
So yeah, to be clear, Simian for us is a real replacement for everything we do with the Monkey backend. So it not only can distribute packages that we create, but it acts as an Apple software update service as well. And we can, just like we have with our other Monkey installation, an unstable testing and stable track, we can do the same thing with Apple software updates. So if we feel that there's some update that might be risky, especially point updates from Apple sort of lately, those go through a vetting process of going out to people in unstable first, then testing, then stable. Things like iTunes lately, we just sort of promote them right away because, I don't care. Go get iTunes, right?
We can also set force install dates to Apple things, which we do a lot.
Yes.
Because as we've said before, some people like to ignore updates. This one has our best logo, definitely. So Cauliflower Vest is a strange name, I will agree. It is an anagram of File Vault escrow. I mentioned earlier that when we encrypt a disk with File Vault, we upload the recovery key that it generates, and Cauliflower Vest is our solution for doing that. It has a backend that again runs on App Engine. We like using our own tools at Google. And then a front end that does the encrypting and the recovery key collecting and the uploading to the server. The name is now a bit of a misnomer because it also handles BitLocker and Lux for Linux, and just about any other type of key you could possibly want to store in it, and it does it securely. The UI is possibly not its greatest feature, but we are planning on fixing that at some point.
People very rarely see the UI, so
that's true.
They should see it once, ever.
And for anybody in this room who's still running 10.7, shame on you, but if you are, Cauliflower Vest does still support 10.7. When 10.7 was first released, we had to reverse engineer how it worked, how File Vault worked, to get the recovery key, because Apple did not have an FD setup tool. So we wrote one, and then they wrote one. So we have some things that we haven't got around to releasing yet, because we sometimes have other things to do.
Or they're still sort of in the very early stages.
Yeah. So like a lot of companies, we've had a netboot server for a long time. Server is probably not the right word. Servers, many. An installer is our way of, when we get into a netboot environment, putting the images down onto a machine. It's an ObjectiveC app with a simple GUI. You pick a disk, you pick an image, and it installs it for you. It's configured with a plist, so you can change your images easily, and you can mark an image as only applying to certain models of machine. So if the people installing the images are not necessarily your most technical users, they should still be able to manage to get the right one every single time. It reports all of its progress as it runs along, and it's been working well for us for a long time. Unfortunately, we're getting rid of our corporate network for security reasons. Some of you may have heard of Beyond Corp. We think that the idea of having a corporate network is over. That's dead. That was a long time ago. But that means we don't have netboot anymore. So we repurposed installer into MacRestore, and it's basically the exact same utility, but now instead of running in netboot, you just run it on another Mac, and you connect your target Mac with a Thunderbolt cable or a USB cable. And this is great because it can download the image once and store it and then cache it. And then you can just restore 10 machines in a row. You just keep plugging a new machine in and it will restore to it. And over Thunderbolt, that takes
under a minute. Well under a minute.
So we just have one machine set up and you just keep plugging new machines in and click start. It's very quick.
Yeah, so basically MacRestore allows any Mac to become an imaging station for any other Mac.
And it's configured with a plist in the same way. Works nicely. GMenu is our answer to the fact that not everybody likes to drop into a terminal, and lots of our tools require you to drop into a terminal. So instead of changing all of your configuration settings or running management tools from a terminal, we've created GMenu. And it's a menu bar application with plugins. And you just write a plugin and drop it in the right place on disk. And as long as it's signed correctly, it will appear in this menu. Everything above the horizontal line is a different plugin. So we've got ones for repairing the network configuration and getting new certificates and getting notifications from a server. Preferences is probably our favorite. It lets users change all these little knobs that we add.
Without dropping into terminal and typing defaults right, blah, blah, blah.
My favorite plugin is definitely Snake. I am personally responsible for wasting many hours of Google's time. There are several thousand people have played this now. I feel a bit bad. The high score is 86. I have no idea how somebody managed to do that. So we'll be releasing GMenu with a few of the plugins. We can't release them all, but Snake will be one of them when it comes out.
And the final item on that menu was management tasks. And we expose the information that we gather using the Run It tool to end users through management tasks, and they can get a historical view of what's been eating up CPU, what's been running the most on their machine. Certain people obviously don't care about that, but our engineers tend to care about that very, very much, especially when they're getting frustrated that their machine's too slow.
It's all relative.
It's all relative.
You can also run the management tools from there, which is nice.
Yes.
Another tool that our team didn't write, but a closely related team did, and we use a lot, is GR. So in case it hasn't been obvious, we care a lot about security and we're quite paranoid. Despite that, sometimes things happen that we didn't expect, and we have incidents. And GR is our tool for going and finding out what happened after the fact. It does remote live forensics. So you can have it, you can target machines based on a huge number of crazy criteria, and you can extract bits of memory or files from the disk. And it all does this from a nice UI that's much better than you would expect. And you create hunts, basically, for malware. So now some tools that we didn't write and we don't use, but we think are really cool. Docker.
That may be of service to you.
Yeah,
although
probably.
Certain groups at Google do use Docker.
That's true. Well, we have Kubernetes, which goes with Docker.
Yes,
anyway,
that's true.
So this is nothing to do with OS X, it's actually Linux. It's Linux containers, which are a lot like virtual machines, but without all of the overhead and slowness of running a second OS inside your OS. So Docker lets you run applications or services and keep those services contained away from other services so they can't interfere with each other. Whilst it's a tool for Linux, it's useful for MacAdmins because you can, for instance, set up a monkey server on a Linux box and have it kept separate from your NetBoot server.
And there is some project that allows you to run Docker containers on OS X.
Yes, it creates a Linux machine.
Yes.
And I'm not going to talk any more about this because there's another talk on Friday at 9 a.m. And they will tell you all about how you can use Docker for Macs. Monkey in a Box is a great project for quickly setting up a monkey server and auto package together on an OS X server. So if you're using an OS X server, this is a great way of getting going quickly with these tools that we've mentioned.
And the author of that, Tom Bridge, I think I saw him somewhere at this conference. I don't know if he's in this session, no, but the author of this is somewhere at this conference.
And it's written.
He's here. Okay.
That's in
good to know.
Bash, right? That one's Bash.
I think it is.
Yeah. So one of the things that we rely on a lot is our logging and analysis pipeline. Unfortunately, that is related to our production stuff, so we can't open source any of that, I don't think. It nothing to do with us anyway. As we can't open source that, Prometheus is a great alternative. It will help collect logs and analyze things, particularly over time, and create nice time series graphs for you. I haven't used it, but I have heard people who have and are very happy with it. I mentioned our Cauliflower Vest tool earlier. Some people, for some reason, are a bit wary of putting their escrow keys on App Engine. I can't imagine why. Graham Gilbert wrote a tool that basically does the exact same thing. His has the advantage that it has a much nicer UI. Ours isn't even as good as that. And his will upload your file vault keys to another server that you host.
That you set up. Pretty sure it's a PHP-based project. So wherever you can get Apache running, you can set up a crypt server. All right, now we've been talking about all this open source that other people make and that you can just go off and download and use yourself. You know, what if you're looking to create your own open source software, as we hope you all do? We love it when you share even the smallest snippets of things, especially in the Mac community. You know, we love seeing people's solutions. Sometimes there are some very clever solutions to problems that we're all seeing as we admin our Macs. So if you're going to create your own open source, one of the first things you need to do is write something to open source. So you need to choose something to write your utility that you're going to share in. That could be using Bash. You might find you quickly outgrow Bash, but even sometimes a small Bash script is worth sharing if it's doing something clever. But yeah, after about 4 or 5 lines of Bash, you'll find you've outgrown it. And after that, most people in the Mac community look to Python. And Python is a pretty good choice. It's a well-constructed language. It has a bridge to Objective-C, and you can get to Cocoa libraries. You might find you outgrow Python at some point, but I think Python can hold you for a pretty long time. And in fact, if you are interested in this, there happens to be a session just for you, the best parts of Python, specifically tailored for system administrators, Friday at 9 a.m.
Python's a great choice for open source because there's a lot of people in this community who know Python and will help contribute. If you write in some weird language that no one's ever heard of, you're less likely to get people contributing.
Very true. And that weird language would be called Objective-C. No,
it's not weird.
Objective-C is, no, it's not weird. It's a great language. Obviously, for a very, very long time, this is where Apple was pushing you to go if you were going to write any sort of utility or tool or program for OS X or iOS for that matter. So Objective-C is still worth learning. If you have a long history invested in Objective-C, I still think you're safe for a very long time. And again, there's a lot of expertise in the community, and you can find Objective-C answers on Stack Overflow and just searching in general. Of course, another option is Swift, brand new language from Apple. I know it got a lot of people really excited when Apple announced it, especially the sysadmin community. People seemed to think it was going to be easier. I'm not sure it actually turned out to be easier, but if you are starting a brand new project, it would probably be worthwhile looking to Swift. Swift also, as compared to Objective-C at least, looks like it will not only be a compiled language, but it looks like you can use it as a scripting language as well. So I think there are some more developments to come on that front, but Swift might be worth your while if you're looking to build a new utility. And at this very conference, if you are interested in this, want to build apps for Mac OS X, come see how to do it with Swift, Thursday, 10:45. The other thing to make mention of is that here we are, 2015. If you're talking about open source, that also probably means you're talking about GitHub, for better or for worse. There are alternatives. There's Bitbucket. I can't think of many others. Like there was SourceForge, but that's kind of fallen off a cliff, and I would say is
full of malware.
Is full of malware. So I would actively avoid SourceForge at this point. You could set up your own Git repository, using Gitolite or some of these other programs. But for the most part, people are sharing their stuff right on GitHub. So if you've never used GitHub, we're not going to get too deep into it here, but there's a great help page right on GitHub, help.github.com. And right from that screen, right from their help page, they're really great about walking you through this if you're new to Git. Set up Git, create a repository, fork a repository, and be social. So their help pages are excellent if you've never used GitHub, but you will need to use the Git commands that we talked about a little earlier and a few more. But GitHub is really great about showing you exactly how to get set up, post your source code. GitHub also gives you GitHub pages, so you can set up a little web page for your project. They give you an issue tracker, so when people do find bugs with your code, they can report them in an issue tracker, and you can track them. So it's not just an email that you get, and then it scrolls out of your inbox, and you're trying to find it, and you forget about this bug that someone reported. And the other unique thing about GitHub is that They support something called a gist. They call it a gist. So instead of a full repository that you're setting up, you can just share a small snippet of code. And for anyone in the OS X server channel on Freenode IRC, you know that people are doing this all the time. Hey, how'd you solve that? Oh, here, I'll just post a gist. And it'll just be a short snippet of code rather than, oh, hey, go dig through all the source code in this big project. So GitHub is really, really handy. If you're not familiar with it already, you probably should get yourself familiar with it.
We should also mention that for anybody who tries using Git and still gets confused by the horrible interface that Git has, GitHub actually have an app for Macs that works great with the website, works great with your local repositories. I think a new version just came out. It's even nicer.
There are a number of GUI tools for Git for the Mac, which is great, but if you don't know where to start, I would start with the GitHub one as well. It's free, right? They give it away, and like Russell said, it works great in conjunction with the GitHub website. So just before I end, since you're thinking of writing your own open source software now, in The Cathedral and the Bazaar, which first described all this open source software, Eric Raymond had a list of 20 or so quotes that he felt were important to open source projects. I picked out a few that I thought were kind of important markers. Every good work of software starts by scratching a developer's personal itch. Yes, if something is bugging you and you need to go scratch that itch, open source it because you're probably solving this problem for many other people in our community. Good programmers know what to write. Great ones know what to rewrite and reuse. And yeah, we've learned this, like Russell talked about before. There are times where we were going to write our own tool or start writing our own software, but we found something in the community that already did what we wanted, and we would much rather contribute back to those utilities and open source projects rather than doing something totally separate. If you have the right attitude, interesting problems will find you. Yes, you will. If you're curious and want to solve problems for your end users, you will find all sorts of things that need code written to go solve them. When you lose interest in a program, your last duty is to hand it off to a competent successor. I'm not sure I 100% agree with this, but if you do come up with an open source utility and there are people relying on it, it really would be nice if you could find someone else who wants to take it over in the community when you can no longer maintain it for whatever reason. Treating your users as co-developers is your least hassle route to rapid code improvement and effective debugging. Yeah, like all the stuff that we write, it's for our end users, really. It's for the people who need to get stuff done in our companies or the people that we support. And yeah, if you work alongside them and with them and get to see what they're facing day to day, you will find interesting problems. The next best thing to having good ideas is recognizing good ideas from your users. Sometimes the latter is better, and we've definitely found that, where sometimes you come up with a list of priorities and things you think are the most important, but then you talk to the people using all this software that you've written or using the machines that you support, and they say, no, this other thing, if this little thing was just solved, it would free me up from doing all this other stuff. So you might want to prioritize what's blocking your users more than what's blocking you. A security system is only as secure as its secret. Beware of pseudo-secrets. And I liked this quote specifically because, as Russell said, we focus a lot on security with what we do, and security is really, really, really difficult to get right. If you are not already a security expert and need to write some code and you want to open source something that relies on security, have a security expert look at it and vet it. We are very, very lucky to work with some security experts who can look at our code before we release it, and they can kind of beat it up and tell us how to fix things, especially things that deal with encryption. Don't do that yourself. Find either a trusted library that already does what you want, use Apple's secure transport, but yeah, don't use like ROT13 to try to encrypt your secrets. Find a security expert. And if all this talk has piqued your interest in open source, and you are on the fence about open source versus commercial solutions, this very conference has a session for that. Open source versus commercial steel cage deathmatch. At Thursday, 3:15. That's the first one that like doesn't conflict with anything else we mentioned, I think. But yeah, that should be a good debate. I mean, we do think open source is very important, but I think we should be conscious of not letting it sort of split up our community. You know, whatever gets the job done for you is probably the most important thing. Different solutions for different cases, and that's our talk. We're here all week. Don't forget to tip your waitstaff. And I guess we have a few minutes for questions if anyone has any questions. Thank you. There you go. And I think I'm supposed to go get a microphone. Oh, that's not a, well, anyway. Oh, okay, there's the answer. If you have a question, go to the mic in the middle of the room. Or I'm supposed to repeat it. Or repeat it. Anyway, we have a real mic. Hi.
Yeah, hi. Do you already deploy Santa to all the end nodes? And if so, like how many binaries are in the whitelist?
So yes, we do, but it's currently only in monitor mode.
Okay.
So it's not actually blocking anything except for the yes program, yes. Nobody uses yes, thankfully. So that's been our test program throughout development. We are collecting all of the events that it's generating, so we should know fairly soon how much is running. And also because it has a log, our security people are also looking at that, so they already know how many binaries are being run. I'd estimate it's in the tens of millions at this point, based on the few analyses I've done, which have been small and not very scientific. Yeah.
When do you guys plan on open sourcing the things that you said were coming soon?
So the question is, when do you plan on open sourcing those things you said that are coming soon? It depends on the project. Some are closer than others. I think GMenu is really
GMenu will be next. That will be in the next month.
GMenu will be next. That's pretty much done, and we just have to file sort of the internal form that says, hey, we're going to do this.
Installer will probably be after that. I wrote the code 3 years ago, and I haven't looked at it since, so I just need to clean it up. GMac restore will take a bit longer, because we only wrote it fairly recently, and there's still a few bugs. We don't want to give it out to people and say, hey, use this. It has loads of bugs in it. That means it doesn't really work. So it shouldn't be, I don't know, before MacTech, at least.
Coming soon.
That one will be 2 months, 3 months, maybe. Yeah.
Anyway. No, go.
Do you two personally have a way to vet stuff that you pull down from GitHub when you're trying to look at stuff?
Yeah, so
repeat the question.
So the question is, how do you vet things that you pull down from GitHub? How do you vet this open source software that you plan on using internally? And yeah, we do have a little process for that. There's if we are going to use software, we do have to download it from GitHub. We check it into our source code repository under a special branch of the tree, so we know it's not Google-owned software, but it is something that we're using. We usually need to get a security review on it, so we let those security experts kind of pore over it and do their job with it. So kind of depends what it is. We vet it more for fitness of purpose, and we'll do a quick security check before we send it off to our security people, but we do have people look at source code before we just go deploy it on 64,000 machines. Yeah, so microphone.
If you're using Monkey to deploy a binary, but then you're using Puppet to deploy the configuration, how do you figure out whether that binary already is running on the laptop before Puppet installs something?
Yeah, so that was sort of one of the reasons we started looking at something besides Puppet. Back in the day, before Monkey even existed, when we were using Puppet only to manage these machines, yeah, that was a problem. Someone, there's a new version of Firefox, and of course, someone is using Firefox, Puppet just comes along in the background, plows over everything, right? And now they lose their profile, and it was not a great solution for that. So that's sort of been our dividing line. When we say we manage configuration in Puppet, we don't necessarily manage an application's preferences. We're just managing machine state. Like, go set the screen, make sure the screensaver isn't set to greater than 10 minutes or so, something, right? Like machine state, but all application updates are going to come through Monkey for us. And Monkey has that functionality built in that if an application that is trying to update is in use, it prompts the end user, throws up a dialog and says, oh, hey, there's an update for this thing, and you need to go quit the current running version. So Monkey has that solved for us.
There are a couple of tools that we have to be a bit careful. Like sometimes you can just put the configuration down before the application, or vice versa, and it doesn't. We mostly tend to put the configuration down first, and it doesn't really matter. Occasionally, if you're putting something down that relies on the binary being there, we'll just, again, Puppet have if file exists, which you can do either by making a fact for it, which is a bit tedious, or using inline templates. And then we just check, if this file exists, then put this configuration down as well.
Oh, yeah.
But like we manage Chrome, for instance, we manage a few settings in Chrome, and we just put the configuration for that down. Same with Firefox. Like if Firefox is on the machine, we put a few things down.
All right, looks like we have time.
That's quite rare.
For one more question, but like I said, we'll be here all week. Go.
Have you considered directory-based whitelisting for Santa?
So the question was, have you considered directory-based whitelisting? And the answer is yes. It's actually regex-based because that performs better if you have multiple directories. I only just wrote that code 3 weeks ago, so it's not very well tested yet, but it seems to work. I don't like it. It's not a great security thing to have, because then you can just, if an attacker knows that you're running Santa, and they could probably guess or find out where those directories are and drop things there. But it is sometimes necessary, so yes.
All right. All right. Thank you very much.